Before we learn how to find the volume of a solid by revolving using a disk, let's look back and compare what we've done. First of all, we found the area between the curve, or two different curves. For instance, f of x minus g of x. We go from top to bottom, perpendicular to the x-axis, so we use dx, or we go right to left, perpendicular to the y-axis, using dy. That was finding the area of this shape, the area of the shaded piece. Then we went from area to volume. We still had the same sort of basic shape, the f of x to g of x, but instead of this being the area we were looking for, it was no longer this area we wanted. This became our base. And these heights now became the base of different cross sections, where you found the area of each semicircle and put that in the volume formula. Now we're going to take a region, and it's not going to be the base any longer. Now we're going to take that region and revolve it around a line, either the x-axis, the y-axis, or another line to create a solid shape. Remember, when you revolve something, it creates a circle. So all of our areas now, instead of being squares or rectangles or semicircles, once you revolve, everything is going to be the area of a circle. So all of our new volume equations will be the volume equals the area of a circle, which is pi r squared. So this is the area of the circle times the width, dx, and that gives us the volume from A to B. And this formula gives us the volume of a solid that has been revolved around the x or y axis or a line using circles or disks. So we're going to focus on disks today. In this example, we're going to take the equation f of x equals x squared from 0 to 3, and we're going to revolve this around the x-axis. Since we're revolving around the x-axis, that means we're going to be taking the integral with respect to x. So remember, if you revolve around the x-axis, you take the integral with respect to x. And you know this is a disk because if you're rotating or revolving around the x-axis, if you notice, all of the space here touches the x-axis. So when you revolve that, it'll be a solid. To get this volume of the solid, we're going to cut an infinite number of cross sections, and the cross sections, since we have revolved, are then going to be circles. So here are the circles here, and I'm going to draw a circle right here. And again, just the area of a circle, also called a disk. We have a radius, and the area of a circle is pi r squared. And so to find the volume, we're going to take the area times the width, which is the dx. So we have pi r squared dx. In order to find the area of the circle, we have to get the radius. If you notice, the radius goes from x squared down to the line, y equals 0. So here is the line, y equals 0. Here is our curve, f of x equals x squared. And our radius is this distance right here, or this length, which is going to be x squared minus 0. So the radius is x squared minus 0. And we are just going to plug that in to here. So to write our volume formula, we're going to integrate. And this goes from 0 to 3. So from 0 to 3. And we're revolving around the x-axis, so it's dx. I'm going to go ahead and pull the pi out because it's a constant. And inside, I'm going to put the radius. The radius is x squared minus 0, or simply x squared. And don't forget, our formula is radius squared. So integrating this equation will give you the volume of this solid. And remember, this was a disk because everything from 0 to 3 was touching the x-axis, so when it revolved it, it made a solid shape. If we were to revolve a different object, say this one, around the x-axis, if you notice, there would be an open space here. That open space, when you revolve, creates a solid object with a hole in the middle of it. So then your cross sections are no longer discs, they become washers. They're a circle with a hole in it, and so you have to find the area of this shaded area here, and this is what we call a washer. However, if you would have revolved this shape around the y-axis instead, if you notice, this is solid from 0 to 2 on the y-axis, so it would have been a solid shape, and then you could have used a disk. This equation is x equals y squared, and it is bound by the line y equals 0 and y equals 2. Since we're revolving around the y, then we're going to integrate with respect to y, dy. So the radius of our circles, or our discs, are going to go from the line x equals y squared down to x equals 0. This is the line x equals 0. So each piece, all the way up to here, is going to go from x equals y squared to x equals 0. Since we're revolving around the y-axis and integrating with respect to y, we're going to pull everything off the y-axis. So the y-axis is here. This is going to be y equals 0 to y equals 2, y equals 0 to y equals 2. And our radius, again, remember, area equals pi r squared. So the area of each of these really long circles, we can draw a smaller one here, really, these circles, the pi we're going to put on the outside. So the volume is going to be pi r squared, and every radius is going to be y squared minus 0. You don't have to write the 0 if you don't want. But then don't forget, it's radius squared dy. So when you find the value of this integral, it will give you the volume of this shape. I hope this video was helpful. Have a great day.